morning class. In the series of Fundamental of Maths, earlier we had discussed about the equation of the straight line. In addition to the equation of the straight line, we had earlier discussed about the coordinate geometry. And that coordinate geometry, it was applicable for two-dimensional and the three-dimensional too. So far we had covered about the various type of equation of the straight line, which is entitled as y is equal to mx plus c, y minus y1 is equal to m into x minus x1, the equation of the centroid of the triangle, the orthocenter, and various type of the altitudes of the triangle. So today we will be discussing about the important concept of the coordinate geometry, that is entitled as a circle. So we will be covering some important theorems, deductions based on the circle, and furthermore we will be extending those theorems, those applications, those rules and regulations in order to solve the complex numerical problems. So it is the topic which we are covering in the series of Fundamental of Maths. In the series of Fundamental of Maths, we had discussed about the equation of the straight line, and today we will be discussing about the coordinate geometry part only. It is known as the circle. So as the topic decides here, as the circle, as the topic here, as it is predefined here, the circle. This type of geometric figures we had already learnt in our lower classes, that is basically in the class of 9th and 10th, and we had studied the various theorems associated with a circle. It was basically the arc theorem, the arc subtended by the one part of the circle and the arc subtended by the other part of the circle. Both the arcs will be equal. So we had already covered the various type of the topics here, and we had discussed also the various types. And we had seen in the circle, we had in the lower classes, we had seen that how come the angle subtended by the same arc will be equal. The angle subtended by the same arc will be equal. The angle subtended by the same arc at the center will be double than the angle subtended by the same arc at the circumference of the circle. So that was basically the geometry part, and it was related to the circle only. Now we will be studying this circle in the aspect of the coordinate geometry, keeping in the mind that this topic which we are going to study now, which we are going to study today, it will be covering under the subtopic of the coordinate geometry. So as the name suggests, as the name defined itself, circle. What is circle? So the circle and all the geometric figure, these are the locus of a particular point. We will be drawing one figure which will make our concept more clear. Suppose this is a circle. So how come we had drawn this geometrical figure? How come we had drawn this geometrical figure? With the help of a point. So that point was nothing but the path traced by a particular point. The path traced by a particular point, it is entitled as the locus. So what is the locus? Locus is the path traced by a particular point. It is the path traced by a particular point. Suppose it is 0, it is A. A is the particular point. Okay. So A is the particular point here. So A is the particular point, and the path traced by a particular point, the path traced by a particular point A in such a way that its distance from the center always remains constant. The path traced by a particular point A in such a way that its distance from the center will always be a constant. That constant part is known as the radius of the circle. So we had already discussed here, in this case, the OA is entitled as the radius. A is any particular point. A will be here, A will be here also. No matter where the A is, but A will lie on the circumference, and that particular point will trace a particular path in such a way that its distance from the center will be a constant. That constant part is entitled as the radius of the circle. So as we had defined now, what is circle? The circle is a path traced by a particular point in such a way that its distance from the center will be a constant, and then that constant part will be entitled as the radius of the circle. So that is the radius. The OA is the radius. OA is equal to radius of the circle, and it will be same. It will be a constant part. It will be same, and that is known as the radius of the circle. So in the concept of the coordinate geometry, whenever we are discussing the circle, we will be coming near to one aspect that is known as the equation of the circle. In the geometrical concept, we were discussing about the arc angle subtended by a particular arc at the center and at the circumference. But when we are coming to the concept of the coordinate geometry, we will be taking majorly the equation of the circle, and based on the equation of the circle, we will be discussing the various aspects. Okay, so in this case, the equation of the circle, it is very important. Suppose we had taken the center of the circle as hk. The coordinate of the center of the circle is hk. Understood? And the radius of the circle is a. Suppose the radius is what? It is a distance between the center and the point at the circumference of the circle. So it is, let it is at as a. So the equation of the circle will be x minus h the whole square plus y minus k the whole square is equal to a square. So this is the particular equation of the circle, in which we had taken the center as hk and the radius we had taken as a. So this is the particular equation of the circle, x minus h the whole square plus y minus k the whole square is equal to a square. So in this case, in this equation of the circle, the question will be like that. Suppose in this equation there are three unknowns are there, h, k and a. In the question there will be two known parameters will be there, and we will be told to calculate the third parameter. Suppose in this case the coordinate of suppose the coordinate of center is not given and the radius is given. So in that case we will be using this particular formula to calculate the coordinate of the center. As we had already studied, the coordinate is the location of a particular point in the space, and it is basically related to the coordinate geometry. So this is the important part. This is the equation of the circle, where we had taken hk as the center of the coordinates of the center and a is the point on the circumference of the circle, and it is the path traced by a in such a way that its distance from the center will be a constant. So we had already deducted a formula here, x minus h the whole square plus y minus k the whole square is equal to a square. This is the equation of the particular circle. Okay, so in this case there will be various parameters. There will be at least 5 to 6 conditions will be there. How we are calculating that, how we are deducting the equation of the circle when we are taking the axis part, when we are taking the you can say the reference as an axis, how we are calculating the equation of the circle and how we are applying those concepts in order to solve our complex numericals. So we will be taking some of the equations of the circle one by one in order to solve a particular problem. Okay, so first and foremost, there are certain conditions, there are certain terms and conditions, and we will be taking slowly one by one in order to make our concept more clear. Suppose the first concept is, whenever we are taking the equation of the circle in such a way that, so when the center of the circle coincides with the origin. So first and foremost is, when the center of the circle coincides with the center of the circle, that is with the origin. So as the condition it is given here, when the center of the circle coincides with the origin. Coincides means that particular origin will be the center of the circle. That is 0, 0. 0, 0 is termed as the origin. So that will be the center of the circle. Now we will be drawing as per the terms and condition. This is a particular axis. We had already studied 0. X-axis is the horizontal part and y-axis is the vertical part. So when the center of the circle coincides with the origin, here the origin is, the coordinates of the origin is 0, 0. So whenever the coinciding part will be there, it will be like this. So this is the circle in which the coordinates of the center is 0, 0. This is the coordinate of the center of the circle, that is 0, 0. So as we had already studied, the equation of the circle is x minus h the whole square plus y minus k the whole square is equal to a square. Understood? Here the h and k are the coordinates of the center and a is termed as the magnitude of the radius. So we will be substituting the values of h and k from that figure. As it is already known that the center of the circle coincides with the origin. So we will be taking the origin coordinates as 0, 0. The x minus 0 the whole square plus y minus 0 the whole square is equal to a square. So finally we are getting one equation, x square plus y square is equal to a square. Since this is the equation, this is a particular equation when the center of the circle is origin, or when the center of the circle coincides with the origin, that is particular coordinates of the origin is 0, 0. This is the equation of the circle. We will be taking the second condition. The second condition we will be taking when the circle is passing through the when the circle it is passing through the you can say when the circle touches the x-axis. Suppose when the circle touches the x-axis, we will be taking one condition. When the circle touches the x-axis, as we are knowing, the original equation is x minus h the whole square plus y minus k the whole square is equal to a square, where h and k are the center of the circle and a is the radius of the circle. Understood? So the second condition is when the circle touches the x-axis. Circle touches the x-axis. So in this case, we will draw one coordinate axis, that will comprise of x-axis and y-axis. Understood? So it will be x-axis and y-axis. When it is given here, when the circle touches the x-axis. Now, whenever the circle touches the x-axis, the figure will be like this. Whenever the circle touches the x-axis. So this is the particular figure where the circle is touching the x-axis. Understood? So this is the particular figure whenever the circle touches the x-axis. So this part, the circumference of the circle is touching the x-axis. So the coordinates of the center will be like this. In this case, we will be using this. Suppose it is A, and it is the center of the circle, it is HK. So we will be using the center of the circle, it is H and K, and the radius it is A. Suppose this part is A, so total part it is A here, it is given. It is the total part, it is A here, it is given. So we will be taking the consideration of the circle is like this. We will be using the coordinates of the center. So suppose the H is the X, H and K. The coordinates of the center is H and K. The first part it is x-axis and the K it is y-axis. So in this case, whenever it comes like this, so this distance will be H. So this distance will be H. And what about K? What about the coordinates of the y-axis? It will be A. So it will be A here. Because we have taken the distance from here to here, that is also A. The center is A. So in this case, the transformation in the x equation of the circle will be like this: x minus h the whole square plus y minus a the whole square is equal to a square. Understood? So this is the particular equation of the circle whenever the circle touches the x-axis. In the case of the x-axis, this is the radius. So this is the radius A, and this is also the y coordinate A. So this will be A and this distance will be x. So the coordinates of the center will be HA. So we are writing the equation of the circle as x minus h the whole square plus y minus a the whole square is equal to a square. That is only the equation of the circle. X minus h the whole square plus y minus a the whole square is equal to a square. This is the second condition. Now we will be seeing the third condition whenever the circle touches the y-axis. Whenever the circle touches the y-axis. So we will be taking one equation whenever the circle touches the y-axis. Earlier we had seen the x-axis condition. Now we will be taking the y-axis condition here. we'll be taking the condition as y-axis. Whenever we will be drawing one coordinate axis like here, this is the coordinate axis, this is the origin, this is the x, this is the x dash, y and y dash. Now it is given the circle is touching the y-axis. As per the terms and condition, the circle will touch the y-axis only. So in this case, this is the A. This is the radius of the circle, and the radius of the circle, it is parallel to the x-axis. So that will be the coordinate of that x. That will be the coordinate of x. That will be the center will be like this. It will be A. Understood? It will be A. The radius will be A. So the center will be A here like that. It will be A, and it will be K. So in this case, the center we will be getting, the coordinates of the center will be A and K. A is also the radius of the circle, and the radius of the circle is parallel to the x-axis. So we are taking the x coordinate as A, and the y coordinate will be similar, that will be K. Now we will be formulating the equation of the circle as x minus, we will be substituting the values of A and K in the original equation, that is equation 1. So it will be x minus a the whole square plus y minus k the whole square is equal to a square. So this is the particular equation of the circle whenever the circle touches the y-axis. So we had seen the three conditions. The first and foremost, the circle coincides with the origin. Secondly, when circle touches the y-axis, and third is the when the circle touches the x-axis. Sorry, it is the y-axis, and earlier to that we had discussed already this whenever the circle touches the x-axis. So in this case, it is evident, it is clear and evident that the center of the coordinates of the center of the circle will be AK. How it is AK? I had already discussed. This is the A, this is the radius of the circle, and that radius of the circle is parallel to the x coordinate. So in that case, the distance will be A, and that will be the coordinates, the x coordinate, and K will be this part, this y coordinate. So this is the center of the coordinates will be AK, and the radius will be A. So finally, the equation of the circle will be x minus a the whole square plus y minus k the whole square is equal to a square whenever the circle touches the y-axis. Now the fourth condition we will be seeing. So we had already seen the three conditions. Now the fourth condition we will be seeing. The fourth condition is when the circle touches both the axes. Suppose when the circle touches the both axes, circle touching both axes, both axes. So in this case, whenever the circle touches the both axes, so we will be drawing one axis diagram here, and we will be drawing one circle which touches both the axes. So in this way, whenever any circle is touching both the axes, suppose 0 it is their x coordinate, the horizontal it is x, and the vertical it is y axis. So as according to the condition of the question, the circle is touching both the axes, that is x axis and y axis both. So in that case, we will be entitling the coordinate of the center as A and A, that is AA, because from here to here that is also radius, and from here to here that is also radius, and the particle both the radius are parallel to both the axes respectively. So we are taking the coordinates of the center as A and A. Now we will be transforming the equation number 1 into this way. Suppose it is x minus a the whole square plus y minus a the whole square is equal to a square. So this is the particular equation of the circle. This is the particular equation of the circle whenever the circle is touching both the axes, the x-axis and the y-axis. So in this way, we are transforming the main equation into our equation of our use into our crude equation, that is x minus a the whole square plus y minus a the whole square is equal to a square. So these are some of the terms and condition. Now we will be saying the fifth one. Earlier we had seen the three condition whenever the circle is coinciding with the origin, the first question. The second was when the circle is touching the x-axis, and when the circle is touching the y-axis, when the circle is touching the both axes. Now we will be saying the fifth condition. It is also one of the important aspect only. We will be saying the fifth condition, and that will be also an important concept only, which will render the transparency afterwards. That is fifth one. The fifth one is whenever the circle passes through the origin and center lies on the x-axis. The circle is passing through the origin and the center is lying on the x-axis. Circle passes through origin and center lies on x-axis. As the question demands, the circle is passing through the origin. So we will be transforming the question into our numerical approach. So first and foremost, we will be drawing one axis entitled as x-axis and y-axis. As we had already studied, the horizontal one is x-axis and the vertical distance is y-axis. So we will be using the concept there as per the terms and condition. The circle passes through origin. The circle is passing through the origin and center lies on the x-axis. So it will be like this. So it will be 0, 0. Suppose it is A. So here, as the terms and condition, the circle is passing through the origin here 0, 0, and the center is lying on the x-axis. The center is lying on the x-axis as it is predefined, as it is already it is defined here that the y coordinate will be 0. Whenever any point lies on the x-axis, its y coordinate will be 0. It is an important aspect and we should keep in mind before approaching further. So in this case, the center is lying on the x-axis. We had already told you that the center coordinates is h and k, and the center is lying on the x-axis. So in this case, the k coordinate will be 0, only h will remain. So here will be h0. Okay, so we had got both the terms which will form one equation. So we will be transforming the equation as x minus h the whole square plus y square is equal to a square. So this is the particular equation of the circle in which we had taken the coordinates of the y-axis as 0 and the x-axis coordinate will be h, and we had transformed that equation into x minus h the whole square plus y minus 0 the whole square is equal to a square. So this is the terms and condition. This is the particular form of the equation whenever the circle passes through the origin and the center of the circle lies on the x-axis. So this will be the equation here. Understood? So so we had already discussed about this part. Now we will be saying one other example. So sixth term, the sixth condition we will be seeing when the circle passes through the origin and the center of the circle lies on the y-axis. So we will be checking that terms and condition also. As we had already discussed the 5 terms and condition, it is the sixth one. It is the sixth one. So sixth one is also an important concept only. Circle passes through the origin and the center of the circle lies on the y-axis. So we will be drawing one diagram here, the schematic diagram, which is depicting the demand of the question here. So it will be 0. The horizontal distance is x-axis, the vertical distance is y-axis. It is the center coordinates is 0, 0, and the center lies on the y-axis. So I had already told you that whenever any point lies on the y-axis, the x coordinate of that particular point will be 0. Similarly, whenever any point lies on the x-axis, the y coordinate of that particular point will be 0. So we will be applying that concept here also. So in this case, the center lies on the y-axis. The x-axis, the x coordinate will be 0 and the k. So this is the particular point where the center lies on the y-axis and the circle is passing through the origin. Now, the circle is passing through the origin and the center coordinate is 0k. So we will be calculating the value of the radius. The radius will be using the distance formula. It will be k square is equal to k. So we had got the value of radius. The center coordinate we had already found out. So we will be transforming the equation number 1 into our equation of use. So it will be x minus 0 the whole square plus y minus k the whole square is equal to k. Understood? So this is the particular equation of the line in which we had already told you that the center coordinates is already given, x minus 0 the whole square plus y minus k the whole square is equal to k. So if we are taking the value of the radius as a, so we will be writing here a. So in that case it will be y minus a the whole square is equal to a. So this is the particular, these are certain terms and conditions associated with the circle whenever we are solving the problem of the circle associated with the coordinate geometry. In the earlier classes, we had also solved the problem related with the concept of the circle, but in that case, we were dealing with the angle part, the arc part, the angle subtended by a particular arc at the center, or the angle subtended by a particular arc at one point, and that angle will be equal to the other point within the circle. So we had extended those concepts into the concept of the coordinate geometry, and today we had discussed about the equation of the circle, how we are calculating the unknown parameters. If in an equation the three parameters are known, the two parameters are known, how we are going to calculate the third parameter. Apart from that, we had discussed about the 6 parameters, the 6 terms and condition. How come the equation of the circle is generated from their terms and condition? Whenever the circle passes through the origin and the center lies on the x-axis, y-axis, whenever the circle touches both the axes, what will be the equation of the circle? Whenever the circle touches the y-axis, then in that case, what will be the equation of the circle? So, as per the terms and condition, we had generated the equation of the circle from that original equation of the circle, that is x minus h the whole square plus y minus k the whole square is equal to a square. So, in the series of fundamental of maths, we had formed the foundation of the equation of the circle. Based on this concept, we will be solving the complex numerical associated with the questions coming in the exam related to the circle. So please just go through my video and observe it and like it and subscribe it, and do share it also. If you are facing any difficulty, please write in the comment box, and as soon as I see whatever the issues you are facing, and I will try my best so as to resolve those queries in the next class. So thanking you for the day. Have a nice day. Thank you.